For our next panel, Big Geospatial Data and AI. Please welcome to the stage Michael Sheetz, Rachael Martin, and Nathan Kundtz.
Good morning. Thank you everyone for being here. Just to kind of set the stage, we got to hear a lot about big rockets. Now we're going to talk a little bit about big data and how space and what the whole conversation about artificial intelligence today, how those two are interacting and where this all goes from here. As you heard in the intros, I'm Michael Sheetz. I'm CNBC space reporter. Covering space is all I do, and it's really been amazing to watch over the last few years as groups like Space Capital have brought folks like yourselves into the room, into the conversation. So I'm really pleased to be a part of this conversation and leading a discussion around geospatial and artificial intelligence. Rachael and Nathan, thank you so much for joining me today. It's great to have you guys on this panel. Before I get into the kind of nitty gritty of the topic, I do want to hear a little bit of defining of what you guys really do. So Rachael, I'm going to start with you. Talk to me a little bit about Project Maven and what you at the NGA are doing.
Sure. So I'll start with what is NGA? So National Geospatial Intelligence Agency. We are both an intelligence community agency as well as on the DoD side, a combat support agency. You may have heard of our counterpart, the National Reconnaissance Office. So they launch them and then we tell them where to go. And then we are also responsible for processing and understanding all the information that comes back from our overhead systems. Maven started as one of the DoD's AI pathfinders in 2017 and recently came over in the last year and a half to NGA. It is focused on artificial intelligence around computer vision, so detecting objects and activities in image or video.
Thank you so much, Rachael. And Nathan, for you, I mean, you're the private sector expertise here. You spent some time in the satellite antenna world, and now you're diving full in on AI. Talk to us a little bit about what you and Rendered are doing.
Yeah, so if you think about the computer vision tools that Rachael just mentioned, those are sitting at the interface of this exponential growth in terms of space capabilities and exponential growth in terms of artificial intelligence and what's happening there. But to actually use artificial intelligence, you actually need the data to train. And so imagine a world where your satellites need to change every 2 years. But in order to actually build the systems to use your satellites, you have to have deployed them, collect data for 6 months or a year, then train something, see if it works and validate it, and by the time you're done, the satellite is out of date. So what we do is we actually provide a suite of tools to be able to simulate that data ahead of time, and not just sort of a few examples, but en masse, large-scale examples that are useful for training artificial intelligence systems. In order to do that just requires a whole variety of different tools and sort of knowledge transfer. And so we provide that as a platform.
And I want to frame this conversation in the realm of what is geospatial artificial intelligence and kind of what that means to each of you. Because I think that's a helpful way to bring everyone else along with us, is to help understand a little bit on how you're thinking about this and what that truly means. So Rachael, I want to start with you. When you think of geospatial AI, what does that really mean?
It's actually a fairly complex area in the sense that there are many different kinds of geospatial data, and they're not all necessarily going to use the same kinds of AI techniques to derive value. And so my program, as I mentioned, we focus on computer vision, which is object detection and images, but overhead systems really produce a range of different kinds of geospatial data that are not just image-based, right? And so depending on what particular sensor or what kind of modality you're looking at, you may want to use different AI techniques. So when we talk about using AI for geospatial, it can be both the sort of let's find an object in an image, and it can also be now that we have these billions of geospatially referenced data points, how do we understand them in a way that can provide value? Because at a certain point, and in particular, as Nathan mentioned, as the volume of that data grows, it is beyond the capacity of a human mind to be able to derive any kind of useful understanding from that kind of data. So you can sort of boil it down to two different things. One is the image-based geospatial AI, and then there's the geospatial data-based AI, which are both related and connected to each other, but can have different applications.
Nathan, do you kind of have a different perspective on that? Is that match what your
I think it's
experience
just
is?
maybe helpful, especially for this audience, to like expand on what we mean by image. Because everybody's like, oh, I've got a cell phone camera. Is that what we do? Like, great, we got images. And it's like, okay, so geospatial imagery can be kind of like that if it's RGB, but there's also there's hyperspectral satellites that have, instead of like 3 bands, 3 colors, might have hundreds or thousands of colors that you're looking at. There's radar-based imagery. There's thermal-based imagery. There's a whole variety of different types of sensing. And in particular, like, to do it effectively, those systems then need to interact, because you actually look at something with one and then you say, oh, I need to see this again from that. And by the way, it turns out most of the Earth is either dark or covered in clouds, and so how do we actually get down there and see things? It's a very complex sort of operational environment to work in.
You know, that's a really good point. You know, one of the examples we like to talk about is, because everyone knows, you know, you can go and find, find me images of cats or find me images of dogs, and it's really easy, and they'll come up with lots of different pictures. But when you look at, something that you have shot from space, whether it's, radar or electro-optical, it's such a small pixel size that it really makes the challenge of building those AI models even exponentially harder than you would have from, sort of commercial application of, a picture that you might have in your phone, for example.
One of the fun examples I like to share on this is like, so we worked with Planet that wanted to look at methane plumes. And you're like, well, what does a methane plume look like? And how would I know that I'm even looking at one? Well, let alone, like, how would I quantify how much methane is in there? And so, you really do have to come at that from sort of an oblique way and sort of, use large-scale simulations to even build out your analysis tools.
To kind of maybe put it another way, analogy that really comes to mind when you talk about it in that realm is, it's almost like a CAPTCHA test that we take when we're clicking on all the stop signs, right, or trying to find all the traffic lights, except the image is a single pixel size, and you're actually not looking at it through human lens, like our eyes. Like, we can't actually see it. So it's a CAPTCHA test you can't see, and it's extremely tiny.
Yeah, just like a CAPTCHA test, I can't pass it anymore.
So when we think about what all this data that's coming back from the satellites in orbit, I want to talk about the interaction then between the AI side of things, the analysis, the identification, and all of the data that's being gathered. Because I think that's a really important piece of this conversation, is just how much capacity is up there in all those different ranges that you're talking about. So it's not just the visual, typical Earth observation of a color image of the planet, but it's all these other wide varieties, and they're being collected all the time, and they're being brought down all the time, and they all need to be made sense of in realm of each other. So talk to me about how much the satellite capacity, when you talk about how much data is being brought down, is there a way you can quantify it for us? I mean, how much satellites are bringing back down to Earth just right now?
Like in gigabytes?
Yeah, I mean, gigabytes are helpful, but I think in a range of just the sheer amount of data that's being brought back down to Earth is almost an overwhelming amount to kind of conceptualize. And I think that's the piece where artificial intelligence is so critical to what geospatial AI is. So just as a scene setter, I think the thing that folks maybe like is helpful to understand is just how much data satellites are bringing down all the time, and the fact that it doesn't stop at any point. I mean, is there a way that you guys think about conceptualizing that and quantifying that? Maybe it's not gigabytes, but another way.
Maybe I'll.
Yeah, so I don't have a number off the top of my head, but I mean, you could recall the graph from the last presentation, last panel, and just sort of how that curve keeps going up, right? And so for every one of those launches, every time you put up a new satellite, you have now another sensor that's also collecting more data. So every one of those represents, again, it's an exponential increase in data. It's not just an exponential increase in space launches. It's all of the things that now are going to continue on a daily basis to be delivered back to somebody, in theory, to look at, right? And we've always thought, the more we put up, the more data, the better it will be, and we'll know what's going on everywhere. Now we're in a position where you have satellites everywhere, but now there's so many of them that you still don't know what's going on everywhere, because you couldn't possibly look at all that data and understand it in a helpful way.
I mean, I think if you look at that growth curve, and I thought it was a phenomenal, every 18 months. Well, it turns out the number of geospatial analysts is not doubling every 18 months. That's not happening. And in the government side, that means now everything really needs to happen with computers. On the commercial side, we never had banks of analysts. So it's almost a funny question to even ask, because if you talk to a commercial company selling satellite imagery, there's no opportunity to monetize anything unless you can pass it through an AI system. That's sort of a fundamental premise. And it was, in fact, it was working with early stage businesses that I came up with the idea of Rendered, because you talk to these guys and they'd say, we want to monetize using artificial intelligence. And you say, how are you going to build that? And they say, well, our plan is to raise $100 million, build satellites for 3 years, launch them into space, collect data, and then we'll see if we can help anybody. And you're like, that sounds like a tough go-to-market strategy.
Nathan, I think that's a really nice transition point into what you guys are bringing to the table and how synthetic artificial intelligence is added into this equation. So how are you trying to fill that gap and try to help provide a basis for training these models and actually supporting all these, instead of having 1,000 analysts, actually having one AI model to sort through all that data?
So I want to make sure, I start by we didn't invent simulation and we didn't invent analysts, or AI, right? But if you say you want to use simulation to be able to train artificial intelligence, you've moved, maybe without realizing it, but you've moved from a world where you need to do add digital twin and add simulation example, to one in which you have to envision all possible examples, a whole distribution of all the things that you could see. And capturing that as a set of procedural generation techniques, as a set of content, as a set of knowledge, and then being able to codify that in a way that can actually be tasked so that you can generate these tens or hundreds of thousands of examples for every application area for every type of satellite is really a Herculean task, right? So what we did was we really tried to understand which pieces of that undertaking are reproducible, which pieces really can be productized so that we have machinery that accelerates it in the same way that when Amazon was building up AWS, right? They figured out which pieces are really are required no matter what type of thing you're building, and then stood up infrastructure associated with that.
It's a really helpful piece of the puzzle then for the analysts and folks that are trying to make sense of all this data. And I want to use that, now that we've kind of set the stage of this conversation, to transition into kind of a conversation of a little bit of the nitty-gritty and the changes that you both have seen in the satellite industry and the geospatial broader landscape, as well as in the artificial intelligence landscape. So for you, Rachael, with Project Maven, it's been around now for several years. It's really kind of coming into its fore now. What are some of the really most significant changes that you've seen since in your time at the NGA, and what have you had to adapt to along the way?
So I think the biggest changes that have occurred, they kind of occurred as Maven was growing up. And so we've had the program for about 1.5 years now. A lot of the changes that have occurred were really when the program started, none of the DoD didn't really know how to buy AI. They didn't know how to build it. They didn't know where to put it. They didn't know what it would take to actually do it in a way that would make it useful for our operational end users. And so there was a lot of lessons learned over that time. And so they didn't have, at the time, some of the massive investments the government has made in cloud. They didn't have any kind of infrastructure. They didn't know they needed labeled data, right? They didn't know how much labeled data they would need. And I think some of the biggest changes that we've seen now is where we currently sit is not only do we know that, but there's many other parts of our IC and DoD who also know that, right? And so now we have many more programs and offices that are looking at the same technologies and deploying them in a very modern way. And so there is a great deal more interest, I think, within our community and then external on the commercial side to be able to participate in that technology development. Again, when sort of Maven first started, there wasn't really a lot of commercial firms that were interested in getting into the space. And now on the commercial side, particularly in the geospatial realm, there is a very much larger number of companies out there who want to be part of helping us evolve solutions to some of our challenges. And so I think that's been one of the big changes. And of course, I know we're kind of doubling down on this data, volume of data issue, but that really is the other big change is the amount that we have to look at really has driven changes in the way we need to do analysis at the agency, and so that we can actually take advantage of some of the technologies. It's just to jump sort of briefly back to something that Nathan was talking about, just talking about sort of the volume or all the different kinds, right, of sensors that are out there. And so our analysts, they need to be able to use all of those. But from an AI perspective, that's also a challenge, right? That's one of the things that we have a challenge with, because every one of those different sensors that's available now has a new AI model needs to be trained on it. And so that's also been, from us, a change, is we had fewer things to focus on in the past, and now we have so many more sensors that we have to look at.
Gotcha. So it's the evolution in the variety of data that's coming down that the challenge that you're trying to tackle now is how to apply the artificial intelligence you're building to all that different variety. I mean, how, when you think about it from a thought process of how do you tackle that problem, what are some of the things that people should know about how you go about kind of biting off and sorry, if you will, just like starting to eat the elephant, if you will?
Yeah, so I think one of the sort of interesting, contradictory things is, on the one hand, we're talking about how we have all this organic data that we're collecting, and on the other hand, now we have this need for synthetic data. And I think you square the circle by understanding that just because it's on the Earth doesn't mean we can always find it. And we do rely on and look at synthetic data as an opportunity to be able to envision objects of interest in areas where we may not be able to see them. So, right, from a national security perspective, our adversaries are not interested in putting objects of interest out where we can find them. And so in many cases, right, we have to use that technology to help us imagine what they might look like in other scenarios that would be of interest to us. And so that is one of those areas where, as we eat the elephant, we need to understand what is the diversity of data we need to have. Like, what are the objects of interest? Where do we want to focus? And in doing that, do we have a picture of this object in this environment, and do we have it in this area, and what's the look angle, and what's time of day is it? Because all of those things drive and influence how the AI is going to read that particular piece of image or data when it receives it. And so there are many cases, despite having all of the data in the world, where we don't have what we need in order to make the AI performant. And so we do start, for all of our AI projects, we always start with the data and what we have and what we don't have, and then figure out how do we get what we don't have so that we can make the model more performant as we continue to develop it.
You were asking before about like what's changed. And I think it's worth highlighting, especially for this group, right? Like 8 years ago, if you said you were working in AI, people were like, oh, you must have a PhD in statistics. Like you must have gone to Stanford, right? And in the last 8 years, it's become so easy to get access to these models and train. And anybody in this room could go and in 30 minutes train a computer vision algorithm from any variety of open source sources. And so what has moved in terms of the difficult part is everything has become about the data. So like when you can hear even as Rachel is talking about this as a problem, she didn't even talk about the algorithms. Like the algorithms are known. It's immediately a question of, do I have the training data to actually train the algorithms, to actually teach them what to look for? And I think that that's a paradigm shift and a mindset shift that maybe within the ecosystem is almost, it's like the frog in the water as it boils. Like we didn't realize until suddenly, like the only thing we ever care about now is whether or not we have access to data.
Just to put kind of the two pieces of the puzzle from each of your perspectives here together, it sounds like what you're talking about then is, from the NGA's perspective, you have to kind of imagine the threat before it even exists, before you even know what to look for in that threat. And from Nathan's perspective, you're trying to say, hey, I can show you what that threat would look like, and I can just create it for you in the data itself, so that those different models are being trained on them before you actually get to identifying it.
And I'm not getting into like any operational details, but the type of thing you want to be able to do is say, like, I'm looking for things like this. I have a lot of data, it's unlabeled, so I don't know if that thing's in there, but I'd love to go look for it, right? At which point you can start to get this mix of like real data and synthetic data together, and your algorithms just become that much more powerful.
Yeah, it's a bit of looking at for hay in a haystack as opposed to needle in a haystack.
Yeah, exactly.
So when we talk about the satellite-based data and the different variety of sensors, you mentioned kind of the capacity, the challenge of bringing those into full use, but I want to talk about their effectiveness, because for a lot of folks in this room, when they're thinking about maybe investing in one satellite company or another, thinking about what kind of sensors they're putting on those satellites, what kind of data they're trying to get back down. In your work, are there any different parts of those sensors where you're like, hyperspectral data is the best, geospatial data available? Is there a way that you quantify and think about the sensors up there from this is the most valuable to this is the kind of most benign? Because when I think about it, I think about, like a 10-meter resolution, typical RGB image is probably one of the least useful because it's not very high resolution and it's kind of in only these 3 bands. Whereas if you have an incredibly low resolution, centimeters of synthetic aperture radar data, that's really useful. Is that the same way that you guys think about it?
So I think the biggest thing to think about when you're looking across the different kinds of sensors is that every one of them is probably going to have a use case where it is most useful, right? There's going to be something about that particular sensor that's going to be really great for one mission area and probably not great for another. So, for example, if I'm trying to find tanks on a battlefield, I'm probably not going to use like a hyperspectral sensor to do that. I don't know how effective that would really be, but using electro-optical is probably going to be my best bet, assuming it's not cloudy outside. But hey, maybe I'm looking in an area that's super rainy and I need to have synthetic aperture radar, and so that's the kind of sensor I'm going to rely on. So it really depends on what you're talking about. A lot of so one of NGA's lesser known missions is we actually do humanitarian assistance and disaster response. And so for that particular mission area, they would want to use something that's looking more at hyperspectral or the shape of the earth and how things might have been affected from a natural physical perspective. But that's not necessarily something that another part of the agency is going to care about because they're doing something else that's a different mission area.
So horses for courses, I absolutely agree. I will say on the analytics side, the analytics, especially in the commercial world, are most mature on electro-optical and RGB because humans can look at it and label it. And as you move into some of these other modalities like hyperspectral, like synthetic aperture radar, it's a lot harder to generate labeled imagery. So even though you have a lot of data, building the analytics is really quite difficult.
Rachel, for you, before we kind of move on, I want to just kind of touch on the last piece of that change, which is the opportunities that you see. When you think about geospatial AI and maybe the untapped things that you'd love to make use of it for, what are those?
Yeah, I think the biggest area of interest for us right now, so we've spent a lot of time, a lot of years perfecting, getting computer vision to a place where it's operationally useful, and that's great. Finding an object in an image or in a video is very important, but I think as we look to the future, it's more important than take all of those observations, whether they are computer vision or if they're from some other sort of geospatial data set, and be able to make sense of them. And I think that's sort of the next step in evolution from a geospatial AI perspective. And where we see a lot of potential is actually using some of the generative AI approaches that have come out to basically arm non-experts with the ability to expertly use geospatial data. So, for example, right now, if I wanted to understand, which ships were departing San Diego at a certain date and time and were flying this flag and, had their AIS active, but then showed up at this other port at another date and time, and, did I happen to have time coincident imagery of them at the same time? You're talking 4 or 5 data sets that you're going to have either a data scientist do some sort of, machinations on, or you're going to be sorting through Excel tables for a really long time. And neither of those are particularly helpful if you're just the average person who's kind of wants to ask that question. What we can do with some of the generative AI tools that are come out is create the ability for a non-expert to query complex geospatial data and get a response back far more quickly than if they would have to, say, outsource that to a data scientist. And so that's one of the areas that I think shows a lot of promise. And similarly, I think another area is also being able to describe geospatial data in words as opposed to just sort of the numbers or metadata that might come with it. So if I have a lot of geospatial data and it has metadata that says it has date and time, it might have location, it might have what's in the image, I can then I can ask the machine to tell me what's in there. So we get to scene description instead of just object detection, right? So it's sort of a second level, higher level reasoning from where we are right now, I think.
I love that description, and we're sort of moving into this world where non-experts are able to interact with data in more and more sophisticated ways. I think it's important to highlight a lot of those are non-deterministic. So you're no longer using tools that are guaranteed to give you a certain output given a certain input. I'm an engineer by training, so immediately I go to, well, how do I test that? And so, like, from my perspective, one of the big things that will be happening over the next 5 years is not just like how do we adopt LLMs and generative, but then how do we evaluate the performance of those systems, right? How do we make sure that they're either not hallucinating or they're hallucinating at a rate that we can manage, right? What are the checks and balances in the system plan so that we make sure we're making the right decisions?
Yeah, no, 100%. I mean, it's very nascent. I think it's very early. Our approach has always been sort of field to learn, so we are starting the experimentation. But I would agree that we're looking to understand better what test and evaluation looks like for generative AI, and how do we quantitatively assess whether we're comfortable with their performance, and where we're comfortable with using them in kind of what scenarios we're comfortable actually accessing them. So I think that 100% agree with you. That is something that is going to be an interest area in the future.
Both of you alluded to the challenge of unlocking that opportunity, but is there a specific obstacle that you can kind of pinpoint as far as adapting to what you're describing?
We just haven't done it before. I mean, it's
an unknown.
Yeah, it's relatively new.
Unanswered question more than anything else.
The obstacle, I think, is the complexity. It's like the complexity itself, and the fact that you're dealing with all of these systems. You're dealing in environments where each time you do one thing, you don't always get the same thing out, and that's a really challenging engineering place to be, right? Navigating that and figuring out how you establish performance statistically is I think the biggest challenge.
With the remaining time that we have here, and especially because I have two folks who have been around both the DoD and the venture capital worlds so extensively, and with this audience in mind, I really wanted to talk about that relationship between venture capital, startups, the DoD, what the government, what the military wants versus what the startup world and venture capital investors think the DoD wants, and vice versa. So let's start off about just kind of get the question out of the way in the first place. Do you think there's a disconnect at all between the investment and then the intelligence communities?
Yeah, I'll jump on this one.
Sorry, yeah.
Let me get this grenade for you. There's always some disconnect between capital and customers, right? There always is, and certainly that's here. I think that there's been a few macro trends that are worth highlighting, right? One, if you look historically, first of all, DoD and IC have always been important customers for technology development, really forever. So what's interesting is not that that's happening again, but actually that there was a moment in time where it felt like it wasn't happening. And there were two major trends that drove that. One was the consolidation of the defense industry, where at the same time you had venture and a lot of capital going to like social media companies. So if you look at companies in the aughts and the early 10s, there was just a lot of attention paid to this class of business for which the DoD and IC was not an appropriate early customer. But that's odd. Like, it's important to sort of step back and say, wait a minute, that's not how technology's been developed over the last 100 years, right? This is like the weird thing, and we're kind of reverting back to the norm. So that reversion is happening with a couple of trends. One, I think the government as a customer is recognizing that it's not healthy to have only 5 primes, and so you start to see initiatives intended to drive capital back into innovative companies, and those are starting to bear fruit. Like, if you think about the amount of money the government has put into space companies, it's less than 1% of the budget in space given to these entrepreneurial efforts, right? It's a very, very small fraction. As that grows, and there's a lot of effort to make it grow, that's going to create a lot of opportunity for new businesses. The other thing that has happened culturally within the VC world, and just important to highlight, is following the invasion of Ukraine, the whole willingness to talk openly about, not only do we support DoD and IC customers, but it's part of our mission to do that, and we're proud of that, and that's something we talk about openly. That has really changed culturally within the venture capital community in the last 5 years.
And Rachel, from your perspective, I mean, what does successful and effective partnering with a customer, especially one who's not a traditional big prime or anything like that. Startups in this realm, the venture capital world in particular, what does successful partnerships look like?
Yeah, I think for us, what we really appreciate when we partner with commercial technology firms is generally they move pretty quickly, and at least our program, we like to move pretty quickly as well. And so they're keeping pace with the market in a way that we can't, right? They're keeping pace with technology change in a way that's a lot harder for DoD to. So in some respects, we rely on them to help us understand what is ready to be brought into government. Because sometimes it's not. Sometimes it might be great in the commercial sector, but there's not enough maturity for us to be able to bring it into DoD. And so knowing, really what are those technologies that are right at that point where we should be thinking about how they would align to DoD missions. Which for us can be a challenge, because while there's been a lot of investment and changes in DoD in terms of increasing outreach to technology firms, trying to help agencies be better with innovation, bring in small firms, there's been a lot of work in that area. But where we still have a kind of challenge is I have my budget 3 years in advance. Right, so I didn't know 3 years ago that we were going to have this massive, change with generative AI coming out in a really significant way. We didn't know that, and so now I'm 3 years, 3 years later, and we want to know how we can take advantage of that. But I'm kind of stuck with what I thought I was going to do 3 years ago, and that's where we kind of need to be right. We need to be on that time horizon as soon as possible to know what we should be looking at, so that we can take as much advantage and not be too far behind the technology curve as we might otherwise be.
And in your experience, I mean, are there mutual learnings there then between the venture capital and startup world and the DoD?
Yeah, I think one of the things that we bring to the table is that we have hard problems, and if you can solve our hard problem, you can probably solve it somewhere else on the commercial sector. You'll never find data that's more dirty and badly organized than some of the stuff you'll get on the DoD side. I guarantee you, if you can fix our data problem, you can probably fix anybody's data problem. We have highly restrictive networks with lots of cybersecurity regulations. If you can figure out how to operate in our systems, you can probably operate anywhere. And I'll say, at least on Maven's behalf, in the way it's partnered with some of those technology firms is, sort of without naming who they are, they've been able to take some of the work they've pioneered with our program and actually take it to market as a commercial offering, right? So there's at least 2 companies that have taken things they've built with us that they stress tested on DoD systems and then have found commercial applications for it, which we really like, because we would like to generate additional kind of commercial activity in the sector as well. So that's been something that we've been particularly proud of from a Maven perspective.
I think if you talk about the relationship, one of the things that happens a lot with commercial companies trying to enter the DoD is that they want to be able to sell using the same sort of go-to-market actions that you use commercially. And that can be as simplistic as like, hey, we're really interested, we're familiar with this PLG thing where our customer is our user. We just sell to them in a really lightweight way, and then they just use it more and more, and it's great. And that doesn't work. And then they say, well, okay, let me use an enterprise sales tactic where I'm going to think about, I've got a financial buyer, and I've got a technical buyer, and I've got an executive buyer, and I want to separate those personas and try to sell to them. And you're like, well, that doesn't work. You really have to understand, wait, no, there's a co-com that's like the end user, and then there's a program manager sitting at a support agency, and there's a contracting officer here, and the dollars are over here, and they've got to get them all talking to each other before anything really happens. And it's a very different go-to-market process, and it doesn't happen in 6 months either, right? So to do anything substantial requires both the understanding and then the willingness to put the time in to make that happen. But then if you do, right, you get to support some awesome programs.
I was going to ask a little bit more about what successes look like in your experience from the private sector working with the government. I mean, maybe some examples of what you think has been exceptionally successful and you've seen results from when you're not selling to the commercial customer.
I mean, so Rendered is starting to have success. I can't talk about a lot of that openly, but I can talk about some of the things that Kundtz has done. And so, for instance, if you look at the Ukrainian drone boats opening up the Black Sea, right, the Kundtz terminal is the comms link for those, and that's something I'm proud of. And so, supporting that fight is important, and it's been exciting to see commercial technology be able to be used to win.
And Rachel, just to kind of finally wrap this up here, I mean, when you talk about what you might wish you'd see a little more from the private sector, you described working with a really demanding customer who's kind of the ultimate challenge, and you can sell to anybody if you can sell to the DoD. But when you talk about then maybe what you'd like to see more out of the private sector, startups, venture capital, are there any specifics you can give me about what would be helpful?
I think the biggest thing I can think of is, and this isn't something that I'm not seeing necessarily, it's just sort of a kind of thank you and please keep doing it, is please continue to be patient with us. We are getting better. We have made lots of strides in being better at bringing technology into the department. They just understand that we do have some of these structural challenges that prevent us from being as good of partners as we'd like to be in some cases. Nobody's a fan of having no budget for half of the year. So you guys less so than us, since you're the ones that we can't pay if we don't have a budget. So these are just things that we kind of struggle with, and just the way that the department works. And we appreciate the patience and your willingness to partner and help us kind of get to some better solutions for some of our national security challenges.
Well, that's a really welcome plea, I think, and something that hopefully will help a lot of these different sides of geospatial AI start to work together a little bit better as the market continues to grow and develop. And Rachel, Nathan, I really appreciate you joining me and having this conversation. I hope everyone learned something out of it and has some takeaways that they can think they'll be able to apply, whether it's in a realm of what their fund is doing or what their startup is doing. But this has been really helpful as well for my own understanding of where geospatial AI is going, where artificial intelligence and space are continuing to cross those borders. So thank you so much.
Thank you.